Hello dear students. So in NLM first till now we are done with the introduction, basic introduction, and next we are done with the motion of bodies in contact, motion of connected bodies, then Atwood's machine, and the example is based on Atwood's machine. Then we are done with the movable pulleys, and then the system in the equilibrium and how to calculate mechanical advantage system of a pulley system. Okay, so we are done with that. Okay, the next topic is that monkey problem. It is very important problem. Okay, this example is number one. It is in H. Verma, basic concepts of physics by H. Verma, and it is also in textbook. Okay, in the textbook as well. Okay, so very important problem. And this example, there's a possibility this example is every now and then asked in the competitive exams like NEET and JW. Okay, so really important. Okay, at the end of the monkey problem, I will show a shortcut how to do it within less than a minute. Okay, so the example is like this. This is a rigid support here. This is a rigid support, and here we have this a massless string or a rope. Okay, now here suppose here the monkey, this monkey. Okay, now this monkey is accelerating in the upward direction. Suppose it's moving in the upward direction with some acceleration a. Its mass is given, that's equal to m. Now the question is calculate the tension in the string. Okay, the question is calculate this tension in the string. That's what we have to calculate. Okay, so this is example number first. Example number one, that's based on the monkey problem. Simply this is a monkey of mass m. This monkey is going in the upward direction with an acceleration of a, and you are supposed to calculate tension in the string. Okay, so simple. What you do is just simply construct a free body diagram. Suppose this is a monkey here of mass m. तो ऊपर की दिशा में क्या है फोर्स, दैट्स टेंशन. नीचे की दिशा में क्या है फोर्स, दैट्स वेट, which is m multiplied by g. It accelerates upwards or downwards, obviously upwards, so that's this acceleration is a. So simply you will use the Newton's second law of motion, that is m into a is equal to summation of all the external forces. ठीक है ना बेटा? Okay, mass to acceleration is equal to summation of all the external forces. Now we are done with the problem. So this is mass into acceleration is m into a. Okay, now you will have to take care that those forces are to be taken positive, which are in the direction of acceleration, and those forces negative, which are opposite. So take this positive, this negative. तो यहाँ क्या आ जाएगा t minus mg. You have to calculate this t. So t will be simply equal to mg plus ma. So t is finally equal to m into g plus a. Okay, so this is the tension string. That's it. Problem is done. ठीक है ना बेटा? Okay, now I'll generalize it. In general, I will write down like this. In general, I'll write like this. In general, the tension string T, that's equal to m multiplied by g plus minus e. Very important equation. ठीक है ना बेटा? Okay, so you highlight this very equation that T is equal to m into g plus minus a. Okay, positive when it's accelerating upwards. ठीक है ना बेटा? Accelerating upwards. Negative when it is accelerating downwards. As simple as that. When it's accelerating downwards, so the monkey is accelerating downwards, take negative. The monkey is accelerating upwards, take it positive. So t will be equal to m into g plus minus a. ठीक है ना बेटा? So you pause screen and write down important example. Okay, so finally we have calculated the tension string by using Newton's second law of motion, and the tension comes out to be how much? That's m multiplied by g plus minus a. Okay, plus we're accelerating upwards, simply like this. When it's accelerating upwards, or when it is retarding downwards. RD implies retarding downwards, and negative sign when it is accelerating downwards, or when it is retarding upwards. Okay, now there are different situations like this. This is case first. Different situations are there. Case first is like this, that this monkey is accelerating upwards, then what about the tension string? Tension is simply equal to m into g plus a. ठीक है ना बेटा? So tension will be equal to m into g plus a. Case second is like this. Suppose the monkey is, so here I'll write it down. Monkey is accelerating downwards. बोलो बेटा इस वक्त क्या टेंशन होगा? What will be the tension in this very situation? Tension will be simply T is equal to m into g minus a. Okay, tension will be equal to m into g minus a. Now case third is like this. Suppose that the monkey is either moving in the upward direction or in the downward direction with a constant velocity, or the monkey is at rest. So here I will write it down. Monkey is at rest. If it's at rest, or if it's moving with a constant velocity, or moving with constant velocity, upwards or downwards, moving with constant velocity. moving with constant velocity. Moving with constant velocity. In all these cases, if the monkey is at rest, what's its velocity? 0. So what's its acceleration? Obviously 0. When the monkey is moving with a constant velocity, its velocity is constant and its acceleration hence it's 0, because acceleration is the rate of change of velocity. When velocity will be constant, obviously acceleration has to be 0. So in all these cases, in general, acceleration is simply equal to 0. Kya hai acceleration? That is 0. So in this very situation, the tension is simply equal to m multiplied by g. This is the tension in this very case. If the monkey is at rest, or the monkey is accelerating upwards or accelerating downwards with a constant velocity, in all these situations, tension is simply equal to m multiplied by g. In this case, m multiplied by g minus a, m multiplied by g plus a. ठीक है ना बेटा? And then there is one more case, case number 4. So here I will write it down. Case number 4. Case number 4 is that if suppose the monkey is going downwards under free fall. Okay, so if monkey is under free fall, so here I will write it down. Monkey is under free fall. Under free fall. What we mean by free fall? Free fall implies that if the monkey is going in the downward direction and there's only one force which is acting on the monkey, and that's weight, only weight. Okay, so that the acceleration of the monkey is downwards and that's equal to g. That means in this very case, monkey is under free fall implies that a is equal to minus g. ठीक है ना बेटा? Negative sign because it's going downwards, that's why negative sign, and since it's at a free fall implies that it has only one acceleration and that is g, acceleration due to gravity. So in such a situation, t will be equal to m multiplied by g minus g, so that's simply equal to 0. So tension string will be equal to 0. ठीक है ना बेटा? So you will at the end of the day you will have to memorize only one equation for these competitive exams, and that is this: t is equal to m into g plus minus a, plus when accelerating upwards or retarding downwards, and negative sign when accelerating downwards or retarding upwards. ठीक है ना बेटा? Okay, then for example it's accelerating upwards, तो यहाँ positive आ जाएगा, it's accelerating downwards तो negative आ जाएगा. ठीक है ना बेटा? If suppose that it's moving with a constant velocity or it's at rest, in that very case acceleration will be equal to 0. So t आ जाएगा कितना? m multiplied by g simply. Okay, if for example it's at a free fall, तो यहाँ negative आ जाएगा, a will be equal to g, then g minus g will be equal to 0. So tension string will be equal to 0. ठीक है ना बेटा? As simple as that. So that means you will have to memorize only one equation, and that's this, and that's this simplified equation. ठीक है ना बेटा? Now suppose that this mass is given to you, acceleration is given to you, then from there you can calculate easily. You can calculate the tension like this. Suppose the example is like this, that the mass of the monkey is equal, let's take it 20 kg. Suppose monkey, its mass is 20 kg, it's accelerating upwards with an acceleration of suppose 4 meter per second square upwards. Then the question is calculate the tension string. So obviously t will be equal to m multiplied by g plus or minus, plus because it's accelerating upwards, plus a. तो यहाँ कितना आ जाएगा? 220 multiplied by 10 plus 4. 10 plus 4 is 14. 14 and 2 is 28. So 280 Newton. As simple as that. ठीक है ना बेटा? I'll not show another example on this. Okay, it is very simple, straightforward. Okay, so memorize one equation, then there are four different situations. So pause screen, write it down. Okay, next example a bit complicated. Okay, so there are three different monkeys, m1, m2, m3. Masses are given 10 kg, 20 kg, 30 kg. Their accelerations are given. This one accelerates in the upward direction with an acceleration of a1. This one goes in the downward direction with an acceleration of a2. That's also given, that's 4 meter per second square. And this one moves with a constant velocity in the upward direction, v3. And how much is that constant velocity? That's equal to 10 meter per second. Okay, so that's here v3, which is equal to 10 meter per second. ठीक है ना बेटा? Now the question is that calculate the tension in the string at this point. That means t1, t2 and t3, and obviously t1, t2, t3 will not be same. Okay, now अब ध्यान रखो बेटा, this t1 will be contributed by m1, m2 and m3 by the weight of these three different monkeys. ठीक है ना बेटा? And t2 it will be contributed by the weight of m2 and m3, or by the weight of the monkey 2 and monkey 3. Okay, so this monkey first, and this monkey second, and this monkey third. ठीक है ना बेटा? And tension t3 is contributed only by the weight of this. Okay, so how to do it? अब ध्यान रखो बेटा, tension t1 will be equal to, ध्यान रखो बेटा, first of all it's contributed by this, so I will write down here m1 multiplied by g, its weight, plus or minus, plus because it's accelerating upward, so plus a1. Then plus it's also contributed by the weight of this, so here I will write down m2 multiplied by g, then plus or minus, minus. Okay, minus a2, ठीक है ना बेटा? Because this is accelerating downwards. Then this monkey, so contributed by m3 as well, so m3 multiplied by g, then 0. plus 0 because it's moving with a constant velocity, so its acceleration is equal to 0. Okay, now substitute the values here. So tension T1 will be equal to how much is m1? That is 10 multiplied by this is 10. A1 is how much? That is 2. So 10 plus 2 is 12. Plus m2, how much is m2? That's equal to 20 multiplied by g minus a2. How much is g? That is 10. A2 is how much? 4. So 10 minus 4 is 6. Then plus m3, how much is m3? That's equal to 30. So 30 multiplied by 10. ठीक है ना बेटा? Now calculate it. So this is here 120 plus this is here 120 plus this is here 300. So that is 3 plus 1 is 4 plus 1 is 5. So 540 Newton is the tension T1. ठीक है ना बेटा? Okay, so this is tension T1. Simple. Okay, next we have to calculate, suppose this part A, and part B we are supposed to calculate tension T2. Now tension T2 is contributed only by second monkey and third monkey and not by the first monkey. ठीक है ना बेटा? Tension in this string is contributed by the masses below. Okay, so it's contributed by this mass and this mass. So here I will write down m2 multiplied by g plus or minus because this is going downwards, so minus a2. Then plus m3 multiplied by g plus 0 because this is moving with a constant velocity. So then substitute the values. How much is m2? M2 is equal to 20 multiplied by g minus a2. How much is that? That's equal to 10 minus 4, that's 6. Plus m3, how much is m3? That's equal to 30 multiplied by 10. So this here 120 plus 300, and how much is that? That's equal to 420 Newton. Then the same way you can calculate tension T3. It's contributed by only this mass, so it's equal to m3 multiplied by g plus 0. So that will be equal to how much is m3? That's equal to 30 multiplied by 10, and how much is that? That's equal to 300 Newton. So this is tension T3. Okay, so we have calculated tension T1, T2 and T3. Okay, quite simple. There's no rocket science in it. ठीक है ना बेटा? Okay, so you pause screen and write down. Example number 3 is home assignment for you. I'm sure you can do it. Very easy. 3 different monkeys. Their masses are given m1, m2, m3, 30, 40 and 10 kg respectively. Acceleration a1 is given, that is called 2 meters per second square downwards. Velocity v2 is given, that's moving in the upward direction with a constant velocity of 5 meters per second. Then a3 is given, that is called 4 meters per second square upwards. Now the question is calculate tension T1, T2 and T3. Okay, so what you will have to take care of that is this, that the tension will be contributed by all those masses that are below that point, below that string, number 1. And number 2 is that if it's accelerating upwards, take it positive. If it is accelerating downwards, take it negative. If it's moving with a constant velocity, then neither positive or negative, simply acceleration will be equal to 0. ठीक है ना बेटा? So take care of that and try to calculate the T1, T2, T3. I'm 100% sure you can do this. No rocket science in it. Okay, pause screen, write it down. Okay, next example number 4. It's copy pasted from textbook, problem number 5.33. You can check it out from there. Okay, so this monkey is given, its mass that's called 40 kg, and it is given to you that the maximum tension which this rope can withstand is 600 Newton. That means the maximum tension in this can be 600 Newton. Okay, ठीक है ना बेटा? Now the question is that calculate the acceleration of the monkey in that very case. This tension is greater than the weight. If you clearly see, the weight of the monkey is 40 into 10, that is called 400 Newton. Tension is greater, implies that the monkey must be accelerating upwards or downwards? Upwards. Only then the tension can be greater than the weight. ठीक है ना बेटा? So in this very case, it's accelerating upwards, and we're supposed to calculate A. T will be equal to m into g plus or minus plus A. ठीक है ना बेटा? Simple. Now everything is given to you except A. You can calculate A from there. T is how much? That's equal to 600. Is equal to how much is mass? That's 40 multiplied by g. We'll take it 10 plus A. This and this will cancel. So 4 1s 4 15. So this is 15 is equal to 10 plus A. Implies that A is equal to 10 minus 15 minus 10. That's equal to 5 meters per second square, and that too upwards. So this is the answer. Simple. Simplest of the lot. ठीक है ना बेटा? Pause screen, write down. Okay, another example number 5, copy pasted from H. Verma, problem number 38. You can check it out from the H. Verma. So these are two different monkeys, monkey A and monkey B. Suppose this mother monkey and this baby monkey. Okay, now this is the tail of the monkey A. This one, this is here tail of monkey A, and the monkey B that's holding the tail of the monkey A. ठीक है ना बेटा? So mass of the monkey is given to you, that's equal to 5 kg, and MB, its mass, that's equal to 2 kg. Now the question is like this: the maximum tension in the tail here, that means T2 is given to us. Maximum tension in the tail of the monkey A is equal to 30 Newton. Okay, so here I will write down that T2 it's mentioned at its sum, that's equal to 30 Newton. The maximum tension implies that if the tension increase in the tail, then the tail will break. Okay, so the maximum tension which the tail can withstand, that's equal to 30 Newton. ठीक है ना बेटा? Now the question is that what force should the monkey A apply on the rope? That means we are supposed to calculate tension T1. What is the tension in this rope? The force applied by the monkey on the rope is equal to the tension in the rope. That means we have to calculate that. So we are supposed to calculate T1. What force should monkey A apply on the rope in order to carry the monkey B with it? That means the system, both this monkey and monkey B, they are going the upward direction. They are going the upward direction with the same acceleration or with the same velocity. ठीक है ना बेटा? Now there are different situations. So situation number 1 is this, that they are for sure they are going the upward direction. Okay. So case number first is this. Case first is this. Suppose the monkey A and monkey B, A plus B, are accelerating upwards. So here I will write down A plus B, or accelerating upwards, ठीक है ना बेटा? Let's try to calculate in this video situation. Suppose with an acceleration of A, accelerating upwards with acceleration B. Okay, so this is the first case. Suppose both the monkeys are accelerating upwards with an acceleration of A. In that case situation, we will try to calculate the tension T1. So tension T1 will be obviously equal to M1. Suppose its mass is M1, or it's given as MA and MB. So summation of these two masses, this plus this, multiplied by G plus A. But for that, we don't know what's the value of A. We'll calculate A from T2. Okay, so T2 will be how much? T2 will be equal to, it will be equal to mass of B. It's contributed with the mass that is below. So MB multiplied by G plus A. ठीक है ना बेटा? So T2 we know that that's equal to maximum tension, that's equal to 30 Newton. ठीक है ना बेटा? That is how much? 30 Newton. Now what is the mass of the B? So that's equal to 2 multiplied by 10 plus A. Okay, so how much is this? This is 30 divided by 2 is 15. 15 minus 10 is 5. So from here acceleration is equal to 5 meter per second square. ठीक है ना बेटा? This is the acceleration when the tension in this will be maximum, and how much is that? That's equal to 30 Newton. ठीक है ना बेटा? So this is acceleration. Now from here we'll calculate at that situation what will be the tension T1, or what is the force that's exerted by the monkey A on the rope. So we'll try to calculate that. Tension T1 contributed by both the masses, so it will be equal to MA plus MB multiplied by G plus A. ठीक है ना बेटा? Now everything is given to you. From there you can calculate tension T1. So what's MA? That's 5 plus 2, that's equal to 7. Multiplied by G is 10, A is 5, so 10, so that is equal to 15. So this how much? 7 5 35, 7 1 7, 7 plus 3 is 10, so 105 Newton. So how much is tension T1? That's equal to 105 Newton. ठीक है ना बेटा? Now the question is like this: what is the force exerted by this on the rope so that the entire system, or so both the monkeys go in the upward direction? But it's not given to us; they are accelerating upwards. ठीक है ना बेटा? So one extreme case is that both are accelerating upwards, when the tension in the tail will be maximum, and in that very situation the force on this rope will be how much? 105 Newton. And the other extreme case is this, that case B, case second is that A plus B are going upwards with a constant velocity. ठीक है ना बेटा? With constant velocity, that means acceleration in this very case is equal to 0. Okay, so tension in this very case T1 will be simply equal to MA plus MB multiplied by G plus 0. ठीक है ना बेटा? Because acceleration is equal to 0, they are moving the constant velocity. Okay, so tension T1 is how much? That's equal to MA plus MB, that's 5 plus 2 is 7 multiplied by 10, that's equal to 70 Newton. ठीक है ना बेटा? That means so one extreme case is this, that both the monkeys are moving upwards with a constant velocity, tension will be equal to 70 Newton. Another extreme case is that when there will be maximum tension in the tail, that means both are accelerating upwards with this acceleration, and tension comes out to 105 Newton. So the force that the monkey A has to apply on the rope lies somewhere between 70 Newton and 105 Newton. If the monkey A applies a force of 70 Newton on the rope, both the monkeys will move upwards with a constant velocity. If it suppose applies a force of 105 Newton, both will move in the upward direction with a constant acceleration of 5 meters per second. Suppose that the monkey A applies a force of suppose greater than 70 Newton, let's suppose 80 Newton, which is less than 105 Newton. In that very case, both the monkeys will accelerate upwards, and the acceleration will not be 5 meters per second square, rather that will be smaller than 5 meters per second square, and the tension T2 will not be equal to this 30 Newton, it will be lesser than 30 Newton. ठीक है ना बेटा? Okay, you got it? Okay. Now finally I will write like this, that the tension T1, it must be less or equal to 105 Newton or greater or equal to 70 Newton. It must be lying between these two. Only in that very situation the two monkeys, that's monkey A and monkey B, will move upwards. ठीक है ना बेटा? If with 70 Newton, constant velocity, 105 Newton, applying a force of 105 Newton, a maximum acceleration of 5 meters per second. If suppose that the monkey A applies a force of 106 Newton, in that very case the tail will break here, tension T2 will become greater than 30 Newton, it will break. And if suppose the force applied by this monkey on this is less than 70 Newton, then in that very case, both the monkeys will rather go in the downward direction and not go in the upward direction. Taken up beta. So these are maximum allowed values of the T1. Okay, T1 cannot be greater than 105 Newton. It cannot be less than 70 Newton. Okay, so highly conceptual problem. That's why HC Verma is very important. Each problem is a clear a concept. Okay, discuss a concept in detail. Okay, in length and breadth. So you pause screen and write down and appreciate HC Verma as well. Okay, another example, again HC Verma example, problem 37. Try it from HC Verma. Okay, the example is like this is a massless pulley and frictionless pulley, and this is string, a rope that's connected that goes from the monkey to this. So there's a monkey here. Okay, then there's a block, the mass of the block and the mass of the monkey, it is given to you, it is same, exactly same. Taken a beta. Okay, now the question is like this: show that whatever the force the monkey exerts in the rope, suppose that this applies the force, suppose that is equal to T. Okay, so from this very point to this very point, the string is exactly same. तो जितना यहाँ टेंशन होगा उतना यहाँ भी होगा, उतना यहाँ भी होगा, उतना यहाँ भी होगा. So tension here will be also equal to T. ठीक है ना बेटा? Simply the reason is that the string is massless. It is massless and it is frictionless. That's why the tension throughout the string will be same. We have discussed it in detail. Okay. Now the question is like this: that show whatever the force the monkey exerts in the rope, the separation between the monkey and the block remains unchanged. For example, this will apply force on this, so as a result of which this will accelerate upwards. In that very situation, we'll have to prove that this will also accelerate upwards, so that the separation between them that remains unchanged always. Okay, na beta? There are two different ways by which we can explain it or by which we can solve it. So way number one is this: that suppose this will accelerate upwards with an acceleration of a. Suppose that means we have to prove its acceleration is also upwards, and that to a. Okay, na beta? Its acceleration is same in magnitude and same in direction. Only then the separation between the two blocks will remain unchanged. Okay. But what we'll do is this: we'll assume that this accelerates downwards with some acceleration. Suppose that's a dash. We'll assume that this accelerates with an acceleration of a dash and that too downwards. Okay, na beta? If somehow we can prove that this a dash is equal to minus times a, we're done with the problem. The problem is done. Okay, na beta? ध्यान रखो बेटा. We have assumed that its acceleration is a upwards, so we have to prove that its acceleration is also a upwards. But we have supposed that, let's suppose that its acceleration is downwards a dash, which is different from this in magnitude and different from this in direction as well. So if somehow we can prove that a dash is equal to minus times a, we're done with the problem. That in turn implies that this accelerates upwards. It's contradiction, so it accelerates upwards with the acceleration of hence proved, hence the problem is done. Taken a bit. So simple. Okay, if nothing works, Newton's second law of motion will always work. Okay, so for the monkey, what I will do is this: I'll write here this is monkey. So in the downward direction, there's a force that's equal to mg. Its weight will be there, and that's how much that's equal to mg. And in this very case, there's mg in the downward direction. So what I will do is this: I'll use Newton's second law of motion. NLM I. Newton's second law of motion. Number one for monkey. Let's apply for the monkey. ठीक है ना बेटा? So it is simply mass is equal to summation of all the external forces. Okay, mass to acceleration is equal to summation of all the external. So mass and acceleration is equal to summation of all the external forces. ठीक है ना बेटा? So for the monkey, it will be like this: m into a, its mass m, its acceleration is a, is equal to take that force positive which is in the direction of acceleration, that force negative which is opposite to it. So it will be equal to t minus mg. T minus mg. ठीक है ना बेटा? Okay. So from there you can calculate t as well. This equation in turn implies, or keep it aside, this equation first. Number second, for block. Let's apply it for the block. Now for the block, its mass m, its acceleration is a dash. Assume its acceleration is equal to a dash, so ma dash. So ma is equal to, I will take this positive, this negative, because this mg is in the direction of a dash. T is opposite to it, so mg minus m, mg minus t. mg minus t. ठीक है ना बेटा? Okay, so I will write like this: ma dash is equal to minus times t minus m. बोलो बेटा, ये समझ में आया? Simply because this negative sign, it will make this negative and this will be positive. Okay, so here I will write down put first and second. Put first and second. So t minus mg के बदले में क्या लिखूंगा? ma. So this is ma dash is equal to this negative sign, and this t minus mg will be replaced by ma. This and this goes to cats and dogs. So we have this a dash is equal to minus times. Now what does it imply? we have assumed that its acceleration is a dash, which is downwards. It comes out to be a dash is called minus times a, implies that this negative sign implies that the presumed direction is opposite to the actual direction. Okay, that the actual direction of this is a upwards and that to a. So finally we have this, that a dash is simply equal to a and that to upwards. So when its acceleration is same in magnitude, same in direction, it's crystal clear that the separation between the two is not going to change. Okay, that will remain same. Okay, so there's one more solution as well, which we'll discuss later on in the center of mass. That's like this will apply force of T on this will apply force of T on this and all that, and mg and mg. The summation, if we consider this whole system as a single system, summation of all the external force equal to 0, if we assume this whole system. Okay, now in that very case the center of mass has to remain at rest. When center of mass remains at rest, okay, so that means the center of mass will always lie somewhere in between the two. That's one more explanation, but avoid that. Okay, we have explained it on the basis of Newton's second law of motion. I am sure you are following my explanation. There is no rocket science in it. Okay, so you pause screen and write down. Again, very important. Okay, another important problem. It's not monkey problem. Okay, I copy pasted it from textbook, and it is problem number 5.32. You can check it from the textbook. Okay, so important problem. So this here person, a man here, is trying to lift this block of mass m via rope, simply attaching the rope to the block and then trying to pull it in the upward direction, suppose with a force of F, with a force that's equal to F. Okay, and that too slowly implies that the acceleration of this block is equal to 0. Acceleration of this block is equal to 0. He is trying to lift it slowly, implies the very constant, with a very small constant velocity. Okay, and then in this very case, again applying the force via this pulley, so like this F, so here it is F, by force F, or tension the string, that's called T. Okay, so again slowly, that the acceleration of this again equal to 0. In this very case, in the downward direction, there's mg. In this very case, in the downward direction, there's equal to mg. There's mg. Okay, so first of all part is that you have to calculate the force applied by the person on the block in the two different situations. So here we'll calculate this force. So force is simply equal to mg. As simple as that. Its acceleration is equal to 0. So ऊपर वाला force equal to नीचे वाला force, because when acceleration is 0, summation of all the external force will be equal to 0. So upward force must be equal to downward force. And in this very case, again, so we are done with the A part. A part here in this very case, F is simply equal to mg. As simple as that. F is equal to mg. Okay, so force that's exerted by the person on the rope in this case and in this case exactly same, and that comes out to be how much? That's equal to mg. Now the part B is that you are supposed to calculate the normal reaction. Now why you are supposed to calculate normal reaction? The reason is this. If you clearly see, it becomes difficult for the person here to lift this load in this very case in the situation number first. And for the same person, it becomes easier to lift this load. It's easier to lift the load here in this very case. It's difficult to lift the load in this very case. Though the force applied by the person on the rope in the two different cases is exactly same, but still it is easier here and difficult here. That's why we are using this. We are paying for this pulley. We are using this pulley here. Because the reason is that it's easier in that very case. Though the force applied is same. Now the question is, why is it easier? That will be crystal clear to you once we calculate the normal reaction in the two different cases. Okay, so let's try to calculate the normal reaction. Normal reaction exerted by the ground on the man or exerted by the man on the ground, that's one and the same thing. That is action reaction pair. Okay, so for that what I will do is this. I'll try to construct the free body diagram for this man. Suppose it's mass capital M. So here the mass of this man, that's equal to capital M. I'll construct free body diagram for this at this very point. Yeah. Okay, so the free body diagram will be like this. There the force in the upward direction, and that's called as normal reaction. Normal reaction is the force exerted by the ground on the feet of the person. In the downward direction, there is a force, and that's capital M multiplied by G, which is the weight of this person. And in the downward direction, this rope, the person is pulling the rope in the upward direction. The rope is in turn pulling the person in the downward direction like this, with a force of capital M. So that is downwards capital M, and that's in turn equal to M multiplied by G. Again, the person is at rest, so that the net force must be equal to 0. So upward force must be equal to downward force. So the normal direction here, that's equal to M G plus mg. That's simply equal to this mg plus mg. Okay. Now in this very case, let's try to calculate normal reaction in this video. So we're going to construct free body diagram here. ऊपर की दिशा में normal reaction, नीचे की दिशा में बंदे का weight, that's equal to mg. So let's try to construct a free body diagram like this. And now you are pulling the rope like this. The rope is pulling the person in the upward direction, so that's capital M in this case, and that's equal to mg. In the downward direction, there is capital M multiplied by g. So ऊपर वाला force equal नीचे वाला force, n plus mg is equal to mg. So in this very case, n is equal to mg minus mg. So this is normal reaction in the case number B. This is normal reaction in the case number A. Now if you clearly see, the normal reaction in the case number A is greater than the normal reaction in the case number B. That means the force exerted by the ground on the feet, on your feet in this very case, is more compared to the force exerted by the ground on your feet. That's why this person is less comfortable in pulling this block, and this person is more comfortable in pulling the block. The reason is normal reaction. Though the force exerted by the person in the two different cases exactly same, but the normal reaction because of ground on the person in this very case is greater compared to the normal reaction here. So that's why it becomes easier. यहाँ पर ये लिखना आप बेटा. So write down this statement there that the normal reaction in the case number A is greater than the normal reaction in the B, like this. That is why it is easier for the person B to lift the load compared to the person A. Okay, ठीक है ना बेटा? Though the force exerted by the person A and by the person B on the rope is exactly same. Okay, so again conceptual example. That's why I have shown it here. Okay, so you pause screen and write it down. Another important problem, and famously called as Banter problem. ठीक है ना बेटा? So it's like this. There's a person that's inside this box, inside this elevator, and there's a rope that's connected the elevator, and it's going over this massless and frictionless pulley. Then it is held by the person. So there's a person that's inside and it's held by the person. Okay, applying the force in the downward direction. Suppose that's equal to T. So यहाँ T. So from this very point up to this very point, there's a single string. Apply the tension here. That's equal to T. तो टेंशन यहाँ भी कितना होगा T. तो यहाँ कितना होगा T plus T. That's equal to twice T. Because this is massless, implies net force must be equal to 0. Upward force must be equal to downward force. So 2T. T plus T is twice T. ठीक है ना बेटा? Now capital M is given to you, mass of the man that's 40 kg, mass of the elevator is given that's equal to 10 kg. Now the question is that calculate the force exerted by the person on the rope or calculate the tension string. That's one and the same thing. And calculate the force exerted by this base of the elevator on the man, or that is you are supposed to calculate the normal reaction. ठीक है ना बेटा? Okay. Case first is that if the system is at rest or moving with a constant velocity. ये आप याद रखो बेटा. If the system is at rest or the system is moving with a constant velocity, the physics remain unchanged. The reason is that in both the situations, acceleration is equal to 0. ठीक है ना बेटा? Whether the system is at rest, acceleration is equal to 0, or whether it's moving with a constant velocity, acceleration is equal to 0. So the mathematical equations will remain unchanged in both the situations. And B is that if it accelerates, if the system accelerates upwards with an acceleration 2 meters per second square. Okay, so let's try to calculate it. So part A is this. You are supposed to calculate what? Part A is that it's moving with it is at rest or it's moving with a constant velocity, implies that acceleration is equal to 0. And then you are supposed to calculate tension in the string or the force exerted by the man on the string, on the rope, and you have to calculate the normal reaction. In order to calculate tension string, ध्यान रखो बेटा, in order to calculate tension string, I will construct free body diagram for the entire system. That's like this. That's like this. So this is capital M plus small m. ठीक है ना बेटा? It is acceleration is equal to 0. Now for this whole system, in the upward direction there is a force that is T. एक तो ये T और दूसरा ये T. In the upward direction the force is twice T. T plus T, that's equal to twice T. In the downward direction there is a force and that is weight, and how much is that? Capital M plus small m multiplied by G. ठीक है ना बेटा? अब जो normal reaction है ना, when I will construct the free body diagram for the entire system, there is indeed the normal reaction between the feet of the person and the elevator, but they will form action reaction, PR. They will form the internal force, and internal force don't create the acceleration. They don't contribute the acceleration because the force is exerted by the man on the elevator. The elevator in turn exerts the force on the man, the upward direction, and they will form action reaction PR. ठीक है ना बेटा? Now since acceleration is equal to 0, so upward force must be equal to downward force. So सीधे twice T will be equal to capital M plus small m, capital M plus small m multiplied by G. ठीक है ना बेटा? So T will be equal, so this is twice T will be equal, how much is capital M? 40 plus 10 is 50, 50 and 10 is 500. So you have 500, so that means T will be equal to 250 Newton. That means if the elevator has to be at rest, the force exerted by the person on the rope has to be 250 Newton. Okay, so as simple as that. ठीक है ना बेटा? Now next is that you are supposed to calculate normal reaction. Let's try to calculate the normal reaction here. Okay, So B part is that you will have to calculate normal reaction. Now since you will have to calculate the normal reaction exerted by the elevator on the main, so I will construct the free body diagram for the main. This is the free body diagram for the whole system. The next free body diagram for the main. For the main, what's the free body diagram? You will have to see how many forces are there exert on the main. One is this, the force exerted by the rope on the main, the upward direction, that's tension string, number one. Number second, there's the weight of the main downwards. And number third, there's a normal action that's exerted by this elevator upward. So there are how many forces? Three different forces. So one force in the upward direction, that's tension. Another force in the upward direction, that's normal reaction, that is exerted by the base of the elevator on the main. And then in the downward direction there is one more force, and that's weight m multiplied by g. ठीक है ना बेटा? So simply this plus this is equal to this. So T plus n is equal to m multiplied by g. N is equal to mg minus t. mg minus, ठीक है ना बेटा? ऊपर की दिशा में टेंशन, ओके, नीचे की दिशा में इसका वेट, ओके, देन ओके. So in the upper direction tension, in the downward direction weight, in the upper direction normal reaction. Okay, so normal reaction will be equal to, now how much is this mg? Capital M is how much? That's 40 into 10 is, this is 400. ठीक है ना बेटा? This is 40 mass, so multiplied by 10 is 400 minus tension. We have calculated that 250. So 400 minus 250 is how much? That's equal to 150 Newton. So this is the normal reaction. Simply like this. ठीक है ना बेटा? So we are done with the part A, that if the system is at rest, we are supposed to calculate tension, we have calculated that. We are supposed to calculate normal reaction, we have calculated that. In order to calculate tension, construct free body diagram for whole system. In order to calculate normal reaction, construct free body diagram only for the man, only then you can calculate it. Okay? So pause screen and write it down. Okay, अब ध्यान रखो बेटा. The next case is that part B is that if it's accelerating upwards with an acceleration of a equal to 2 meter per second square. ठीक है ना बेटा? Again you have to calculate what you are supposed to calculate, tension and normal reaction. So again, in order to calculate tension, construct free body diagram for the whole system. In order to calculate normal reaction, construct the free body diagram for the main alone. ठीक है ना बेटा? So let's try it. So it's like this. This is here capital M plus small m. तो नीचे की दिशा में क्या है फोर्स? कैपिटल M प्लस स्मॉल m मल्टीप्लाइड बाई g. ऊपर की दिशा में क्या है फोर्स? दैट इज ट्वाइस t. t प्लस t, दैट इज ट्वाइस t. ठीक है ना बेटा? एक्सेलरेट्स अपवर्ड्स डाउनवर्ड्स, ऑब्वियसली अपवर्ड्स. Okay, so in this very case what I will write is this ma, that is equal to m is equal to summation of all the external forces. In this very case acceleration is not equal to 0, implies summation of all the external force will not be equal to 0. So that will be equal to, now mass, that is capital M plus small m multiplied by acceleration will be equal to, take that force positive which is in the direction of acceleration, this positive, this negative, so it will be 2t minus capital M plus small m multiplied by g. ठीक है ना बेटा? Okay, so capital M plus small m, that's 40 plus 10, that's 50, multiplied by a is how much? 2. So this is 50 multiplied by 2 is equal to twice t, minus this is here 50 multiplied by 10, that's how much? That's 500. ठीक है ना बेटा? 40 plus 10 is 50, into 10 is 500. Now this is 2 5 is 10, how much is that? 100. 500 plus 100 is 600 here, is equal to twice t. तो t कितना निकला बेटा? That is 300 Newton. Okay, so we are done with the tension. Calculate the force exerted so that it accelerates with an acceleration of 2 meter per second square. Answer will be 300 Newton. Okay, now next is that you have to calculate normal reaction. For that, construct free body diagram only for the main. Now on main, how many forces? एक तो ऊपर की दिशा में टेंशन, ऊपर की दिशा में नॉर्मल रिएक्शन, नीचे की दिशा में बंदे का वेट, दैट्स m multiplied by g. ठीक है ना बेटा? Accelerates upwards this time with an acceleration of a that's equal to 2 meter per second square. So again ma equal to summation of all the external forces, so it will be like this, m multiplied by a is equal to n plus t minus mg. ठीक है ना बेटा? Okay, you are supposed to calculate this m, so m into a, how much is mass? 40 into 2, that's equal to 80, is equal normal reaction and calculate, plus this is 300 minus mg. How much is mg? That is 400. Okay, so 300 minus 400 is minus 100, so minus 100 यहाँ लाओ, so 180 will be equal normal reaction. बस हो गया, प्रॉब्लम हो गई, डन. ठीक है ना बेटा? Okay, so important example number 1 is really important. There is a possibility it can be asked in the competitive exam. You pause screen and write it down. Okay, ध्यान रखो बेटा. Another example, similar pattern. This one pulley system, another this is one here. This panther plus elevator system, panther plus elevator system. Okay, the question is simple. Calculate the force exerted by the man on the rope so that the entire system is at rest. Simple. You can also calculate normal reaction as well. There is no problem in that. ठीक है ना बेटा? अब ध्यान रखो बेटा. Okay, so from this point up this very point there is one string like this. तो टेंशन इस स्ट्रिंग में सेम होगा. सो सपोज टेंशन हियर दैट्स इक्वल टी. तो यहाँ कितना होगा टी, तो यहाँ कितना होगा टी, और यहाँ भी कितना होगा टी. So t plus t is twice t, so the force here that will be equal to twice t. ठीक है ना बेटा? Okay. Now this whole system is there. Whole system is like this. This is here capital M plus small m. तो ऊपर की दिशा में कितना फोर्स है? एक तो ये t और ये twice t, तो कितना हुआ 3t. नीचे की दिशा में कितना फोर्स? That is weight capital M plus small m multiplied by g. Since the system is at rest, implies net force must be equal to 0, implies upward force must be equal to downward force. So this must be equal to this. So it in turn implies T is equal to capital M plus small m multiplied by G divided by 3. बस हो गया, single line answer. You can do this example orally. ठीक है ना बेटा? अब ध्यान रखो यहाँ. So tension here from this very point. This is like this. From this very point up to this very point, the tension is, this string is same, so tension will be same. तो यहाँ कितना है T, यहाँ क्या है फोर्स 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 T, यहाँ कितना T, T plus T is twice T, so here it will be twice T, T plus T is twice T, तो यहाँ कितना twice T. Now twice T plus twice T is how much? 4T. 4T plus this 1T, that's equal to 5T. So 5T will be equal to how much? Capital M plus small m multiplied by G. नीचे की दिशा में capital M plus small m multiplied by G. So that means simply you can write like this: T is equal to capital M plus small m multiplied by G divided by 5. बस आंसर हो गया ये. ठीक है ना बेटा? Now suppose that you want to calculate normal reaction. If you want to calculate normal reaction, construct three body diagram for this. Okay? If suppose capital M small m is given to you, suppose that capital M, let's take it here. This capital M is equal to, let's take it 30 kg, and small m, let's take it 10 kg. ठीक है ना बेटा? Then calculate T. So T you can calculate, that's obvious. So this is 30 plus 10 multiplied by 10 divided by 3. You can do that, and you can do it here as well. Once you are done with the tension, then you can calculate normal reaction. In order to calculate normal reaction, ये बन जाएगी three body diagram. ध्यान रखो बेटा. This is capital M. तो ऊपर की दिशा में एक तो इस पर फोर्स T है, ठीक है ना बेटा, और ऊपर की दिशा में एक और फोर्स, दैट्स नॉर्मल रिएक्शन. नीचे की दिशा में इसका वेट. So this plus this will be equal to this. Now T you have calculated from this equation, then substitute in this equation to calculate normal reaction. इसी तरह इसकी भी यही इक्वेशन बन जाएगी. ठीक है ना बेटा? ऊपर T, ऊपर M, नीचे mg. But the tension here and tension here will not be same. ठीक है ना बेटा? Tension in this very case will be obviously smaller compared to this. That means this system is more effective system, is a more efficient system compared to this system. Done? Okay. So pause screen, write it down. So one more example here. Again panther problem. This is a panther and this is a platform here. Its mass given that is equal to m. So this is a platform. ठीक है ना बेटा? And then he is pulling two different ropes. So from this point there is string and another string from here. ठीक है ना बेटा? Identical strings. Okay. Now the question is that calculate the force exerted by the panther on one rope so that the entire system is at rest. ठीक है ना बेटा? Okay. So simple. Suppose from this point the tension is same. So this will be T. This will be also T. तो यहाँ कितना है T और यहाँ कितना है T. ठीक है ना बेटा? ऊपर की दिशा में. Now let's construct the free body diagram for the whole system. It is capital M, small m. ऊपर की दिशा में T plus T is 2T plus T is 3T plus T is 4T. ऊपर की दिशा में 4T. नीचे की दिशा में weight capital M plus small m multiplied by G. Equate the two. T will be simply equal to capital M plus small m multiplied by G divided by 4. तो हो गया आंसर. ठीक है ना बेटा? And then suppose if you are supposed to calculate normal reaction, let's calculate normal reaction as well. Okay, so let's calculate normal reaction. What's the normal reaction? In order to calculate normal reaction, we'll construct free body diagram only for the main. तो ये है main, इसका मास है m, नीचे की दिशा में है force, that's how much? Capital M, so capital M multiplied by G. ठीक है ना बेटा? ऊपर की दिशा में T plus T is twice T. Twice T, so simply twice T will be equal, और ऊपर की दिशा में एक और force, that's normal reaction. Okay. So this plus this, so the equation will be like this: 2T plus n will be equal to mg. N will be equal to mg minus 2T. ठीक है ना बेटा? Then substitute the value of T there. From there you can calculate normal reaction. Suppose it is given to you that capital M is equal to, let's take it 20 kg, and let's take small m equal to 5 kg. ये खुद कर लो बेटा. Substitute values and calculate tension, normal reaction. Easy. Okay. Pause screen, write it down. Okay, last question based on the Panther problem. Okay, so it's an S Verma example, problem number 39. Now the question is like this. A similar question, this is a person of mass capital M, this is an elevator of mass small m, and there's a weighing machine inside, and the person is sitting on the weighing machine. ठीक है ना बेटा? Okay. So capital M is equal, this is massless. It is given to you that the weighing machine that is massless. Okay. Then capital M is how much? That's 60 kg. Small m that's equal to 30 kg. Now the question is first of all, A parts like this. Calculate the weight shown by the weighing machine if the elevator is at rest. Okay. So that means you will calculate normal reaction. ठीक है ना बेटा? In order to calculate normal reaction, we'll construct three body diagram for this. But for that we have to calculate tension. So suppose this here T. This also T. ठीक है ना बेटा? Okay. So let's construct first of all three body diagram. A combined three body diagram. Capital M plus small m. ऊपर की दिशा में क्या है फोर्स ट्वाइस टी, टी प्लस टी इज ट्वाइस टी. नीचे की दिशा में कैपिटल एम प्लस स्मॉल एम मल्टीप्लाइड बाय जी. सो सिंपली ट्वाइस टी विल बी इक्वल टू कैपिटल एम प्लस स्मॉल एम मल्टीप्लाइड बाय जी. तो वहां से टेंशन निकलेगा. सो ट्वाइस टी विल बी इक्वल 60 प्लस 30 इज 90 into 10 is 900. सो टेंशन कितना निकला 450 न्यूटन. बट वी आर नॉट सपोज्ड टू कैलकुलेट टेंशन. ठीक है ना बेटा? वी हैव टू कैलकुलेट व्हाट रीडिंग ऑफ द वेइंग मशीन. फॉर दैट वी विल कैलकुलेट नॉर्मल रिएक्शन. And in order to calculate normal reaction, construct the three body diagram for main. So this is main only. Its mass is capital M. Sorry. Okay. So on the main there are forces. Number one is tension in the upward direction. Number second is normal rate in the upward direction, which is exerted by the weighing machine on the person. ठीक है ना बेटा? In the downward direction there is weight M multiplied by G. Okay. So from there we will calculate normal reaction. This is T plus N will be equal to capital M multiplied by G. N will be equal to capital M multiplied by G minus T. N will be equal, अब देखो कैपिटल M कितना है बेटा? That's equal to 60. So this is 600 minus, we have calculated this 450. So the normal reaction comes out to be 150 Newton. कितना? 150 Newton. That means, so this is the normal reaction. Normal reaction implies the force exerted by the person on the weighing machine, or the force exerted by the weighing machine on the person like this. This is your normal reaction. ठीक है ना बेटा? Okay, so normal reaction comes out to be how much? 150 Newton. That means the reading of weighing machine, Wm, reading of weighing machine will be equal to 150 divided by G. That's equal to 15 kg. G is 10, so this 10 and 10 will cancel, so it's 15 kilogram. That means that weighing machine will show a mass of 15 kg. What's its actual weight? That's 60 kg. What it will show, that is equal to 15 kg. ठीक है ना बेटा? Okay. Okay. So you pause screen and write it down. It will show lesser weight. The reason is this tension here. ठीक है ना बेटा? Okay, the reason is tension. The tension is 450, so its weight is equal to 600. 600 minus 450 is how much? That's 150. That's why its weight is equal to how much? 15 kg. So this is called apparent weight of the person as shown by the weighing machine. ठीक है ना बेटा? Okay. So you pause screen and write down. अब ध्यान रखो बेटा. So in the part A, the normal reaction coming out with 150 Newton. अगर आपको याद होगा. ठीक है ना बेटा? Or the mass that's equal to, the reading is equal to 15 kg. Okay. Now the question is like this: calculate the force that's exerted by this person on this rope, so that calculate force exerted by the man on the rope, so that the weighing machine shows actual weight. So that the weighing machine shows actual. And what's the actual weight? ध्यान रखो बेटा. Solution. What does it mean? It means this. What is the actual weight? Actual weight of person कितना है? Actual weight is equal to mg, and that's equal to 600 Newton. It implies that the normal reaction must be 600 Newton. Because normal reaction is 600 Newton, only then the weighing machine will show a weight of 60 kg, will give a reading of 60 kg. ठीक है ना बेटा? So that means normal reaction is given to, that's equal to 600 Newton. And from there we have to calculate the value of T. Now in this very case, this whole system will accelerate upwards with an acceleration of A, which we don't know. Okay. Now here we have two unknown variables. How many unknown variables are here? Two unknown variables. And those two unknown variables are, number one is tension. We don't know what's the value of T, and we don't know what's the value of A. ठीक है ना बेटा? In this very, in the part first there was normal reaction, that's 150 Newton, and we have calculated tension as well in that very case. But the second case we don't know what's T and what is A. So what is the number of equations we require at minimum? The minimum number of equations we require are 2. So we'll construct three body diagram. Number one for the whole system, and number second for the main alone. We have two equations, two unknown variables. Solve them and try to calculate the value of T. ठीक है ना बेटा? We have to calculate the value of T. Okay. Calculate force exerted by the man. So that means we are supposed to calculate the value of T. That means we will eliminate A. Okay. So it's like this. This here capital M plus small m whole system. So what is its mass? 60 plus 30 that's equal to 90. तो नीचे की दिशा में 900, ऊपर की दिशा में twice t. ठीक है ना बेटा? ऊपर की दिशा में t plus t for whole system, t plus t that's equal to twice t, and it accelerates upwards with an acceleration of a. Okay, so what I will write is this simply ma that's equal to 90 into a is equal to twice t minus 900. Twice t minus 900. ठीक है ना बेटा? Simply 90 into a is equal to twice t minus 900. Okay, so this equation number first. Suppose it's equation number first. This equation number first. Okay, then next what we have is this. Next we have the free body diagram for the man only. So this is man whose mass is capital M. ठीक है ना बेटा? And how much is that capital M? That's equal to 60. तो इसका mass 60. तो नीचे की दिशा में 600 इसका weight. ऊपर की दिशा में एक force T, दूसरा force normal reaction. Okay, and it accelerates upwards with an acceleration of a. ठीक है ना बेटा? So what I will write for this is 60a. I'll write like this: 60a is equal to 60 multiplied by a is how much? 60a is equal to how much? That's equal to, this is t plus n minus 600. ठीक है ना बेटा? T plus n minus 600. Okay, so we know the normal reaction as well. And how much is that? That's called 600. So this and this will cancel. This and this will cancel, implies that 60a is equal to t. ठीक है ना बेटा? 60a is equal to t. Now what we have to eliminate is, we'll try to eliminate the value of t. Okay, so this is equation number second. So simply what I will do is this: I will substitute the equation number first, equation number second, the equation number first instead of a. So here I will write down put 2n first. Put 2n first. तो यहाँ क्या लिखेंगे बेटा? So here I will write down like this: 90 multiplied by a. अब a के बाद क्या लिखेंगे? t divided by 60. t divided by 60 is equal to twice t minus 900. ठीक है ना बेटा? Now from this very equation you can calculate the value of t. Okay, so this and this will cancel. This here 3 3s are 3 2s are, so it is 3t by 2. Okay, so it's like this: 900 यहाँ आ जाएगा, will be equal to यहाँ रहेगा 2t, और यहाँ बनेगा ये 3t by 2. So it is 2 2s are 4, 4t minus 3t is 1t, that is t by 2, तो t निकलेगा 1800 न्यूटन. ठीक है ना बेटा? Again I will repeat it. Wait a moment. So this is part B. The question is like this: what is the force exerted by the man on the rope so that the weighing machine will show the true weight, that in the normal reaction must be equal to its weight, which is equal to 600 newton. That's it. And the unknown variables are here: 2, that's t comma a. How many equations we require? 2. So one free body diagram like this, one equation here, this free body diagram, this equation, this free body diagram, this equation. ठीक है ना बेटा? Now what we will eliminate is a, because we need t. So this is this. Now substitute this here. a के बदले अब क्या लिखेंगे बेटा? t divided by 60. So this is t divided by 60 here. This is 2t minus 900. So this and this is here 3t by 2 यहाँ जाएगा, 2t minus 3t by 2 900 यहाँ आ जाएगा. So 2t 2 2s are go for cross multiplication. 2 2s are 4, 4 minus 3 is 1. So t by 2, 29 is 80. So t is equal to 1800 newton. That's it. ठीक है ना बेटा? Conceptual problem, very important. Okay, very important. Repeat all these examples. So in the present lecture, what we are done with is number 1, monkey problem, very standard problem, important problem. I have shown you the examples that are in the textbook and in the experiment as well. And then we have the examples. Then next we have the painter problem, again an important problem. And I have shown you the experiment problem as well. Okay, simply experiment is really the Bible of physics for the competitive exams, especially for JEE mains and JEE advanced. ठीक है ना बेटा? जो NEET aspirants हैं, they can afford to skip the experiment problems, but JEE mains they cannot simply. Okay, so and for today I have some examples for you. I have some home assignment for you. You just write them down. Okay, so you write down the page number on the study material. You write down page number on the study material. Pause screen and try this. Write this yourself. Okay? So you write down the page number. There's page number 82. Okay. Then example number. You write down this 1, 6, 10, 14, 15, 16, 17, 18, 20, 28, 33, 35, 36, 37, 38, 40, 41, 44. Okay, ठीक है ना बेटा? अब एक ही दिन में ये नहीं करनी है. For example, these are suppose 15 examples. Try 5 examples in day first. और 4 examples, 4 examples, 4 examples, 4 examples. ठीक है ना बेटा? Take it easy. Okay, don't panic. ठीक है ना बेटा? Okay, so tata.